Now we're going to start using our balance, and the operation of this is covered in the K3 Physical Science tape. Tell your students that they're scientists working for the Alka-Seltzer company, and their job is to find out the weight of the gas that's given off by one tablet when it's dropped in a half a glass of water. How much does that gas weigh? And all they have to work with is a half a glass of water, a tablet, and a balance. How would you solve the problem? Have your whole class brainstorm it. Give them a few clues if necessary and test some of the incorrect answers. But above all, they're the scientists, not you, and they should come up with a solution. The solution is, of course, to weigh the half a glass of water with the tablet next to it first and find out how much that weighs. And then drop the tablet in carefully so none of the water spills. Wait till all the gas escapes and then weigh it a second time. It will weigh less. You subtract the second weight from the first weight and you get the weight of the gas that's given off. Incidentally, it comes out to be about 4/10 or 5/10 of a gram. I found that the weight of this gas can differ. Sometimes by the tablet it's sat in air for a while, it doesn't give off as much gas, or maybe it gives off more gas when it's put in hot water. So there's a lot of variables you might consider. Another interesting extension is try dropping it in a half a glass of vinegar and see how much gas you get. Now we're also talking about chemical change. Here's a tablet that when it's sitting in air doesn't react, but when it comes in contact with water it reacts. And we know it's going through a chemical change because we see a gas produced. And that gas, incidentally, is carbon dioxide. Let's now take a look at the differences between the physical properties and the chemical properties of a material. Now hopefully from the primary grades the student has an understanding what the physical properties are. The shape, the size, the texture, the color. The chemical properties are a little bit more involved. Things like flammability, does it burn? Solubility, does it dissolve? Does it dissolve in water? How does it react with other chemicals? Now, when we look at chemical properties, it's best to use demonstrations in front of your class, and I like to start out with a piece of chalk. You hold the piece of chalk up and have the students describe it. It's white, it's cylindrical, it's long, all kinds of different things. These are physical properties of the chalk. Then you get a hammer and pound it all up and little chalk dust goes flying everywhere, and you get the chalk and scrape it in your hand and you say, is this still the same chemical? Is it still chalk? The chemical hasn't changed at all, but has the physical properties changed? Yes, they have. It's changed its physical shape, but it hasn't changed its chemical makeup. So it's gone through a physical change. You could crush up ice and do the same thing, but it hasn't gone through a chemical change. Now let's go on one step to another example. I'm driving my car down the street very fast. I hit a telephone pole. Fortunately, I don't get injured at all. The car, though, is a total disaster, and then I get a broom out and sweep it all up into a little pile. Has the car gone through a chemical change? No, all the pieces are still there. The car has definitely gone through a physical change, but not a chemical change. But what happens in the case if the car catches on fire? Parts of the car are now changing their chemical formula. They're combining with oxygen in the air, they're giving off energy, and there's new chemicals being made. The carbon monoxide, the carbon dioxide going up in space are byproducts of this. So now we have a chemical change. We need to get our students to understand the difference between physical changes and chemical changes. And now we have some activities that reinforce this idea. As we investigate chemical changes, we should first become familiar with things that tell us that a chemical change is taking place. There are 4 conditions. A chemical change occurs if any one of the following happen. First, if heat or light are given off. Second, if a gas is produced. Third, if there's a color change. And fourth, if a precipitate forms. Now, what is a precipitate? Some people think that it's rain. But in this case, a precipitate is a solid that forms when we mix 2 liquids together or 2 gases. This first activity can be done either as a demonstration at the front of the room or as a classroom experiment. If you're doing it as an experiment, put about 3 students in each group. Give each group a test tube rack with 5 test tubes numbered 1 through 5. You can have your stock solutions at 5 different locations in the room. Student will take a test tube up to, in this case, solution number 1 and fill the test tube half full. Now what are these solutions? Well, number 1 is our old standby phenolphthalein. And phenolphthalein usually comes from the science supply house in powder form. It's mixed, very small amounts of the powder mixed with alcohol. Even rubbing alcohol works fine, and then diluted down with water to make it work. Solution number 2 is mostly water with a little bit of household ammonia in it, so it's going to be a base. Solution number 3 is also mostly water with a little bit of vinegar in it to make it an acid. Now you should have a little bit more vinegar in this solution than you have ammonia in the number 2 solution, and you'll see why in a minute. Solutions 4 and 5 are made by dissolving these two chemicals in water. And in my case, I only took about a quarter or half a teaspoon and put it in a cup of water. And I used distilled water this time. This first one, number 4, is calcium chloride. Calcium chloride, CaCl2, that's 2 chlorines and 1 calcium atom. The second one is sodium carbonate, and it's used in water softeners. In fact, I found sodium carbonate as a cleansing agent in the grocery store. Now, regardless of whether you do this as a demonstration or an experiment, you should have a handout sheet so your students can record their observations. And if you're doing it as an experiment, go over each instruction beforehand so that you can be sure your students understand what they're supposed to do. Let's go through the motions on this. First, we're going to have our students observe each liquid and record down whatever they can tell about it, without tasting it, of course. And remember, when you ask them to smell it, to hold it an arm's length away and wave their hand over the top and then move their nose closer until they can detect what kind of odor it has. And then we're going to have them hypothesize. What do they think will happen when they pour number 1 into number 2? Well, what do you think will happen? Since they're both clear liquids, I would expect that I would get a clear liquid that's twice the height. Well, let's pour it and see what happens. Remember that phenolphthalein turns to a pinkish red color in the presence of a base, in this case ammonium hydroxide. Now the next question we'll ask them is, what do they think will happen when we take test tube number 2 and pour it into test tube number 3? Well, I would think in this case I would get a diluted pinkish color. Let's now see what happens in this case. Remember that the vinegar will neutralize the base and it will make all the pink liquid disappear. Now what would happen if we took this clear liquid in 3 and poured some of it back into 2? What would happen in that case? Well, let's try that now and see what happens. The vinegar now neutralizes the base and makes the phenolphthalein clear. Now we're through with these 3 liquids. We'll try the last 2. Once again, hypothesize. What do you think will happen? Well, after that first experiment, I would expect this would turn pink when I mix the 2. Let's see what happens on this one. In this case, the liquid goes to a milky color, goes from clear to milky. Now what has happened in this reaction is that the calcium in the calcium chloride has combined with the carbonate in the sodium carbonate to form a white precipitate called calcium carbonate, also known as precipitated chalk, and it's used in toothpaste. If we let this test tube sit for a while, all this white little milky color will settle out into the bottom, and we'll have some white chalk material at the bottom, and we can do that and observe what a precipitate is. Now, how do we know a chemical change took place? Well, first there was a color change in the first 3 test tubes, and in the last one there was both a color change and a precipitate formed. Now let's look at another experiment that we can do. This time we're going to investigate reactions where heat is either given off or absorbed. When the material gets hotter, it's called an exothermic reaction. Exo means outside, and therm has to do with the word heat. Ask your students to think of other words that use therm as a root word. An endothermic reaction is where heat is drawn in, absorbed, and the material gets cooler. Now we've got 2 chemicals to show both of these reactions. One of them is one we've just used, calcium chloride. The other one we're going to use is ammonium chloride. And hopefully you have balances and graduated cylinders available to work with metric units. First, each student group will measure out exactly 150 milliliters of water and put it in their cup. If you don't have these, you can substitute a cup of water. Then each group will use different amounts of calcium chloride. You can have group 1 weigh out 5 grams, group 2 could have 10 grams, group 3 could have 15 grams. You can even have a group substitute the same amount as a previous group so that they could compare values. Then you need a thermometer, and hopefully one with degrees Celsius on it. First, the students will measure the temperature of their water before they add the chemical. And remember to measure the temperature with the thermometer in the water. Once they've done that, they'll add the chemical, whatever amount they're supposed to have, stir it up, and then after 1 minute, measure the temperature again. Was there a temperature rise, or did the temperature decrease? Was it an exothermic reaction or an endothermic reaction? And how does the amount of chemical they used affect the temperature rise or the temperature fall? Now, when using calcium chloride, you'll find there's an exothermic reaction. It gets hotter. And about 2 teaspoons or 10 grams should raise the temperature about 8 degrees Fahrenheit or 4 degrees Celsius. When you're using the ammonium chloride, you'll see an endothermic reaction. It gets colder, and it gets colder about the same amount for 10 grams or 2 teaspoons. Make sure that the students rinse their cup out thoroughly when going from one experiment to the next to avoid contamination. Now, what can you do with the data? Well, one thing is to first calculate the change in temperature so that each group knows how many teaspoons they used and how much the temperature changed, and then graph it. On the horizontal axis, put the number of teaspoons of chemical that were used. And on the vertical axis, put the delta or the change in temperature and put the points in. Is it a straight line? Is it curved? How does it come out? And how do the two chemicals compare? And then be sure and ask them if a physical change took place or a chemical change. And how do they know? Remember rule number 1, whenever heat or light is given off, we have a chemical change. Let's do one more dramatic demonstration this time to show chemical changes taking place. Before we begin this demonstration, let's take a look at test tube number 5. Remember that, the one with the precipitate. We look now and we see that all the little solid particles have settled out at the bottom, and we see fine pieces of white calcium carbonate or precipitated chalk. Incidentally, this took about 5 or 10 minutes to happen. Now what we're going to do is burn the element magnesium, and it comes from the science supply house in the form of a ribbon, metallic ribbon. Break off a piece about 2 centimeters or 1 inch long. You can do it with your fingers. Get the rest of it well out of the way. Have a pair of safety goggles for yourself and for a student assistant if you have one helping you. We're going to have a metal or plastic plate to burn it over so it doesn't drop and burn holes in your desk, and a Bunsen burner to light it off with. It takes a lot of heat to get it going. The first thing we'll do is take a look at the magnesium metal and have the student observe its properties. What does it look like? What does it feel like? Then we're going to put our safety goggles on, light our Bunsen burner up, and light it off and see what happens. Let's do that right now. Hold the magnesium metal in a pair of pliers, and once it lights, get it over the plate very quickly and watch what happens. Ask your students if a chemical change is taking place, and if so, how do they know? Once it's burned, you can look at what's left, the residue, and have your students now describe the material that's left. We started with magnesium, metal, the element, and we've ended out with a compound, magnesium oxide. The magnesium is combined with oxygen, given off vast amounts of heat and light, and produced a compound. A chemical change has taken place.